Hello, in this video let's talk about how to take a derivative if we have more than one function and we are multiplying them. So far we have discussed how to take a derivative of something to the power, which is the power rule. We have talked about the sum and difference. Now let's talk about the product rule. So when we multiply two functions, we take a derivative of each one separately. So we have the product and then we take a derivative of the first function but not the second. Then we add, keep the first function and take a derivative of the second only. So here is an example. On one hand, we could do some algebra and simply multiply these terms out, and then we would have a big polynomial with many terms, and we can take a derivative of each term separately and we will get the answer. That's one way to do it, but that would involve quite a bit of algebra to get the final answer. Or we can simply use the product rule. So let's do that instead. So using the product rule, what we have is, let's take a derivative of the first function and then we'll do the second. So when we learn this in the first time, it may be beneficial to simply rewrite the functions and indicate what it is that we're going to do. So here's what I mean. Let's copy this over and simply show to ourselves what it is that we are going to do. So we have the first function, we have the second function, then we will add them, and we have exactly the same once again. So all I'm doing is I'm copying over the template or the formula and indicate it to myself what it is that I need to be doing. I need to take a derivative of this and then take a derivative of this. So what is the derivative of this polynomial? Well, the first term is the power rule. Derivative of 5x to the 2 is 10x to the first. The derivative of x is just 1, and the derivative of 8 is nothing, it's 0. So the rest of the question is unchanged, and I simply copy it over. And when I get to the last derivative, we'll take that. So what is the derivative of 3x? The derivative of 3x is just 3. What's the derivative of negative 5? Well, that's 0. And that's all for the derivatives. If we have to simplify this function at this point, we could multiply it out and then simplify. And that would give us the same answer as if we multiplied these in the first place and then took the derivative. But this approach is a lot faster and a lot easier to use. Now, we could have more than two functions. It could be 3, 4, as many as we want. And the rule is the same. It simply extends to multiple functions. And here is what it looks like for 3 functions. So suppose I have 3 functions, f of x, g of x, and h of x, and I'm multiplying them. And all I need to do is take a derivative of each one separately and keep the other functions as they are. So once again, let's use the same principle and indicate to ourselves what it is that we're going to do on this example. So here we take the derivative of x cubed. That would be the first thing that we need to do. And then we will keep everything else as it was. X squared minus 1, 5x cubed minus 2. Then we will add to it, we'll skip the x cubed, and we will take a derivative now of x squared minus 1. So this needs to be done with the derivative, and then the rest is the same, x cubed minus 2, and then plus, and the last component is x cubed, x squared minus 1 times the derivative of the very last function, so derivative of 5x cubed minus 2, and the derivative. Now the only thing left to do is simply to focus our attention on each one of these derivatives and figure out what they are. The derivative of x cubed is 3x to the 2. The rest of the question is unchanged, so we carry it over. 5x cubed minus 2. Then x cubed is unchanged. Now we need the derivative of x squared minus 1. Well, the derivative of x squared is 2x. The derivative of negative 1 is nothing, so that's finished. That's the derivative of x squared minus 1 is simply 2x. The rest of the question is the same, so we haven't worked on it, so nothing has changed. Again, this is still the same, nothing has changed. And the final component is the derivative of the last function, which is 15x to the 2. At this point, if we wanted to simplify, we could multiply it out and clean it up, but that's not necessary for this example. And that's it for the product rule. And that works. This rule works for any number of functions when they're multiplied. If you have any questions, please let me know. Thank you for your time.